So now that we've learned all three methods, and let's just review those. So we've done graphing, elimination, and substitution. So what we're going to talk about today is we want to try to figure out how can we find the best method for solving a linear equation. Now, if they give you the option, then you can choose from all three, but if they ask you algebraically, then you can only choose from elimination and substitution. All right? So, looking at this, I would say that because I see this right here, elimination would be the best method. Okay. Again, if you wanted to solve for y for the first equation, you definitely could use substitution. But for this one, the easiest way would be to use elimination. I see that I have additive inverses, so I'm going to use addition. So I'm going to get x equals 3. Substitute that back in. I'll do it for this one. 2x minus y equals 3. So 2 times 3 minus y equals 3. 6 minus y. Okay, so my final solution is 3, 3. All right, so the next thing I want to do is I want to just do the graphing for this too, just to refresh ourselves on that. So if I'm going to graph this first one, I have negative x plus y. So I'm going to add x to both sides. And I get y equals x. So the thing about y equals x is this is just a straight line that goes through the origin. Okay, so it'd be 1, 1, 2, 2, 3, 3. And then it goes all the way back to the other one. Okay, so negative x plus y equals 0. All right, and then if I do the other one, 2x minus y equals 3. All right, so for this one, I'm going to start, this is the b equals negative 3, and my slope is 2 over 1. Okay, so I'm going to do for that, I'm going to start at negative 3, up 2, over 1, up 2, over 1, up 2, over 1. Oop. Okay, notice I'm graphing, or I'm plotting my lines, and then labeling them. Okay, so again, the answer, same thing, 3, 3. All right, we'll go through this one a little bit faster. I just wanted to make sure that you guys had a little bit of practice with your graphing. All right, so this next one, that one should shout right out to you. This right here, we have something that is solved for. So the easiest method would be substitution. Okay, So all I'm going to do is I'm going to take this -2 and I'm going to put it in for the y. So I get 6x minus 3 times -2 equals 18. 6x plus 6 equals 18. Subtract the 6. So x equals 2. Now I'll plug that back in. Oh, just kidding. We already know that y is equal to -2 because it gave it to us. So our final answer is -2. All right. And for sake of time, I already graphed this. Okay. So for graphing this, now, just as a reminder, please remember the line y equals -2 is a horizontal line. Okay, and it goes through -2. Okay, so this right here, this line right here, this is y equals -2. Okay, now for the next one, you have to solve. All right, so when I solved this, I got y equals 2x minus 6. All right. Remember, you can put this into your calculator if you need to. Use calculator. Okay? So if you use your calculator, you're going to get a bunch of points. Use your points, and then you will see that, again, it crosses at 2, -2. 2, -2. Okay? All right, next one. So, Mo's farm stand sold a total of 165 pounds of apples and peaches. Wow. She sold apples for $1.75 per pound and peaches for $2.50 per pound. If she made $337.50, how many pounds did she sell? Okay, so for that one, we are going, and I already did this one too, I will just talk about it. Okay, so next lesson we're going to do more with real-world application problems, but I wanted to get started so that we could have another example. So if you look at this question, all right, and let's underline a few things first. So Mo's farm stand sold a total of 165 pounds of peaches, all right? And then they sold the apples for $1.75 per pound, and the peaches for $2.50 per pound, and this made $337.50. All right, so after that, I see that I need to have two different variables. One variable is going to be apples, the other variable is going to be peaches. Okay, so I'll do this in red and this in green. Okay, so if I have my apples and my peaches, it told me that I have a total of 165 pounds. So I know that when I add the apples and peaches, I get 165. I also know that she made a total of $337.50. Each apple is $1.75 and each peach is $2.50. So when we multiply those and add them, we would get $337.50. So in order to figure out how many apples and peaches there are, what you could do is you would just multiply. So this is the elimination method. Okay, so the elimination method. So using the elimination method, I could multiply the 250 across. I chose to do 250 because it's a little nicer than $1.75. And then I subtracted everything. So when you subtract, you get that x is equal to 100 pounds. So the apples would be x, so it would be 100 pounds. And then the peaches would be 65 because that's what's left over. The other thing you could do is you could, so This is a multiple choice question, right? So if we have 165 pounds of apples, right, we know that, so we want to know peaches. So if there's 65 peaches, that means that this is 100 apples. So what we could do is do 65 times the $2.50, and then the 100 times the $1.75, and add those and see what we get. Okay? So for this, we would have 100 peaches and 65 apples, 100 and, let's see, what's our number? 1. So 155 apples and peaches, and so on. Okay? So what you could do is you could try this into the equation 1.75x for apples plus $2.50 y equals 337.50. So you could choose to do just a single equation question and guess and check, since this is a multiple choice question. So either way, that would work. All right, the next one. Albert says the two systems of equation below have the same solution. Determine and state whether you agree with Albert. Justify your answer. So for this one, what you have to do is you actually have to solve both equations and then compare the two answers. All right, so this is a double whammy kind of question, which I did on the back. Also, this was a 4-point question. I can't remember how many years ago. I feel like it was pretty recent. Okay. So for the first one, I used elimination, and the second one, I used substitution. So this is a really nice example for you guys. Okay. So for the first one, I multiplied the first one by 5 and the second one by 9. Again, this is not an easy question, but it was on the Regent, so it's really important that we practice on some difficult questions and we don't just do the easy ones. Okay, so as you can see, if you solve both of these, you will in fact get the correct answer, or the same answer rather. So we would agree with Albert. So another reason why I added this into your note packet is because this is what would be acceptable to get all of your points for this Regent question. Okay? So it says to determine and state whether you agree. The fact that it says determine and state. Okay? So what this means is you can't just say yes, but you do have to say yes. And then you have to state whether you agree. Now justify, all right, and if you look up on my wall, there is that word justify. So justify means you have to do some math. So I think we did more than enough math here. And then to state, so you have to state that you agree with Albert and that they are equal to each other. You have to state that. All right. So now you should be able to figure out if this is, or what would be the best solution, the best method for this. So again, just like question number 1, I see two opposites. Okay, so elimination again is the best way. So I eliminated the y's, and then I got x equals 4, substitute that back in, and my solution is 4, 2. Just another graphing example. And again, whether you graph or do this algebraically, you will get the same answer. All right, another substitution example. Remember, when one is solved, that should shout out to you substitution. So we take this negative 3y plus 3 and substitute that in. Okay, so when I do that, I get my solution is 0, 1. And then again, graphing this into your calculator is an awesome way to check your work. All right? So I know sometimes it kind of seems like a lot more work than you need to do in order to get done. But it really ensures that you're not going to make a silly error. Alright, so again, I see that negative y and a positive y, so elimination would be best. And that is what the graph would look like. And one more for the road. So 3x minus 2y equals 2. And then negative 5x plus 2y equals 10. That one, elimination would be best.